Morning, students. Once again, I welcome you all for this important session. So, in the previous class, we have studied how to calculate the deflections, that is, short term deflection and long term deflection. So, let us study in this class, that is, cracking in structural concrete. Why the cracks will going to form in the structure, then how to calculate the crack width, that is important. Just like you have calculated short term deflection, long term deflection, similarly we are going to calculate the width of cracks. So that is, first we'll see why the cracks will going to develop in the elements like beam, then slab, okay, lintels, etc. So cracks in structural concrete, that is concrete will going to crack because what? Flexural tensile stress. So the cracks in structural concrete members may develop due to tensile stress, shear stresses, diagonal tension, then due to shrinkage, creep, thermal and aggressive environmental conditions. Okay, so the cracks in concrete may be due to what? Because of tensile stresses, shear stresses, then diagonal tension, then shrinkage, creep, thermal and aggressive environmental condition. If your structure or a building is situated in very severe environmental conditions, then there will be cracks. Aggressive environmental condition means the environmental exposures will be classified like this. Okay, normal condition, normal environmental condition, then moderate environmental condition, then aggressive environmental conditions. Aggressive, like if you consider the structures situated coastal regions, okay, so where there may be chances of developing of cracks in the structural elements. So these are the reasons, because of that cracks in the concrete will going to develop. So the Indian Standard Code, that is IS 456 2000, if you refer that code book and if you go to the clause 35.3.2, okay, so this clause indicates that cracks in concrete should not adversely affect the appearance or durability of the concrete. So even though the cracks are there, if the crack width is within the permissible limit, then there will be no problem or no danger. But if the crack width is more than the permissible, then we need to take care. Okay, so then what should be the allowable crack width? Okay, permissible crack width. Permissible means allowable. So the IS 456 2000 code prescribes the following limiting crack widths in structural concrete members depending upon the environmental exposure conditions. That is, suppose if the building is exposed to environmental conditions, then as per this table, these are the allowable, okay, permissible limits to the crack width. The first condition is the protected and not exposed to aggressive environmental condition, means normal condition. If the building is situated in normal environmental condition, then crack width should not be more than 0.3 mm. So suppose if there is a crack in the beam, the width of the crack should not be more than 0.3 mm. That is for building is exposed to normal environmental condition. Then if the condition is somewhat moderate, okay, somewhat moderate environmental condition, then the crack width is limited to 0.2 mm. Okay, it should not be more than 0.2 mm width of the crack. Then third is, this is important, aggressive environmental conditions like coastal regions. If you see the structures, okay, so there may be chances of development of cracks because of this aggressive environmental conditions also, right? Then in that conditions, the permissible width of the crack is 0.1. It should not be more than 0.1 mm. Okay, so these are the different conditions, and under different conditions these are the limiting widths of cracks. Okay, then how to calculate the crack width, that is analytical method first we are going to see. Okay, that is, or you can say that theoretical method, using that formulas and all that we are going to calculate the crack width. So in case of special structures and in aggressive environmental conditions like what I have said in coastal regions like that, it is always better to calculate the width of cracks. So you have to calculate the width of cracks developed in the elements, then compare them with the permissible crack width. Okay, whatever the permissible this is there now, we have to compare with this. First calculate the crack width using analytical method, compare with these conditions IS 456 2000 criteria, and compare them with the permissible conditions crack width to ensure the safety of the structure at the limit state of serviceability. So this crack width calculation and deflection calculation comes under limit state of serviceability. The Indian Standard Code, that is IS 456 2000, which will going to specify an analytical method. Okay, whatever now we're going to calculate, that is analytical method for the estimation of design surface crack width. Okay, that is surface crack width in annexure F. So if you refer that IS 456 2000 code book, if you go to the annexure F, so there will be a procedure or there will be a method. That method will be described here now. The design surface crack width is expressed as, now using this is the formula, we have to calculate the crack width. Crack width WCR. Okay, CR means crack, W means width. Crack width in the element is equal to 3 ACR into EM. Okay, ACR 3 ACR into EM divided by 1 plus 2 into bracket ACR minus C minimum divided by H minus X. So this formula again you can find this in the IS 456 2000 code. It is not necessary to by this. Okay, just refer IS 456 2000. There you will get to get the this, that is annexure F. Okay, so then what are these terms? So we have to calculate this ACR, EM, then this C minimum, then H, then X. These are the terms we need to calculate. So before going into details of these terms, first see the sketch. Okay, we have marked these elements here. So this is the cross section of the beam. Okay, so this is width of the beam. Okay, then this is overall depth, capital D. Now here in crack width calculation, we are going to show this as a small h. So small h is nothing but capital D, that is overall depth of the beam. What is small d? It is effective depth from top to the center of reinforcement is effective depth. This is overall depth. This is neutral axis depth. Okay, this is neutral axis depth. Now see, the reinforcement is provided like this. Okay, tension reinforcement it is. Tension reinforcement is provided at this, and this is from this bottom of the bar to this bottom surface of the beam. This is called as clear cover. Okay, the bars will not be directly placed on the surface. There will be a gap. Okay, this gap is known as clear cover. Always this should be required. So this is clear cover. Okay, then so from this bottom of the bar and to the bottom surface of the beam is indicated. Clear cover means that is C minimum. C minimum, this term, this C minimum. So this is from bottom of the bar to the bottom surface of the beam is C minimum. Okay, then what is this ACR? This ACR, okay, or this ACR. So ACR is nothing but distance from the point considered to the surface of the nearest longitudinal bar. Refer this figure. Now where exactly the cracks will going to form? Normally cracks will going to start from the bottom of the beam, not from the top. So cracks normally will going to develop from bottom. So always it will going to start from the bottom. So what is this ACR? ACR is nothing but distance from the point considered to the surface of the nearest longitudinal bar. So where the crack will going to form? Crack will going to form from the bottom. So suppose I want to calculate what is the crack width here. Okay, at this point, what is the crack width at the bottom of this beam? So this ACR will be right from this point to the nearest bar, but surface of the nearest bar, that is distance from point considered. This is the point. Now I want to calculate the crack width at this point. So from this to the bottom surface of nearest bar, for this nearest bar will be this. Suppose I want to calculate the crack width at this point. Crack width at this point means, so from this to, for this point, what is the nearest bar? This is the nearest bar. So from bottom of this bar to where we want to calculate the crack width, that is the ACR. Now this is the ACR. Okay, from this to this ACR. So then how to calculate this ACR? For this you are going to use the formula. So ACR is equal to 0.5. ACR is equal to 0.5 S, 0.5 S whole square. Okay, 0.5 S whole square plus C minimum square. C minimum square, then whole raised to 1 by 2. Raised to 1 by 2. Then what is this S now? See this S. The one bar is placed here, second bar is placed here, third bar is placed here. So from center of one bar to the center of another bar, this is called as a spacing. Okay, horizontal spacing. Okay, from center of one bar to the center of next bar is S, that is horizontal spacing. So 0.5 S square, 0.5 S whole square plus C minimum square raised to 1 by 2. So from this C minimum we can calculate this. Okay, and ACR will be calculated from this. So here yes, you can substitute spacing between two bars. Spacing between two bars. Okay. Then what is C minimum? C minimum is minimum cover to the longitudinal bars. So see, from bottom of bar, from bottom surface of the bar to the bottom surface of beam, this is a clear cover. Okay, clear cover is nothing but C minimum. So C minimum is equal to minimum cover to the longitudinal bars. Then X, as usual, depth of neutral axis from the top, depth of neutral axis from the top surface of the beam. Then H, normally in this case we are going to take H instead of capital D. H will be same. D and H are same. H is equal to overall depth of the member. Then what is this EM? Okay, what is this EM? This term we are going to calculate. So EM is equal to average strain at the level of steel where cracking is being considered, and it is calculated by allowing for the stiffening effect of concrete in the tension zone and obtained from this equation. So this EM will be calculated from this equation, that is EM is equal to E1 minus B into H minus X into A minus X divided by 3 into ES into AST into D minus X. So all these formulas are given in the code book. Okay, so EM is equal to E1 minus this term. Okay, so from this you can calculate EM, but if you want to calculate EM, okay, so E1 will be calculated. Okay, E1 you have to calculate, X you have to calculate, A we have to calculate. So what is this E1 now? E1 is strain at the level considering a cracked section. After cracking of the beam, whatever the strain you will going to consider at the level of steel, that is called as E1. This E1 we will going to calculate. Then what is B? B is width of section. Okay, at the centroid of the steel. Okay, at the centroid where the steel is provided, at that point what will be the width of the beam? That is B. So it is same. Okay, whatever the beam width of the beam is given, that will be small b. Then A, what is this A? A is equal to distance from the compression face. Okay, distance from the compression face to the point at which crack width is calculated. Okay, so it is distance from the compression face means top. distance from the compression phase. This is compression phase, bottom is tension phase. So distance from top, okay, top face to the bottom surface where we are calculating the crack width. We are calculating here at the bottom. So from here to here, A. So A is nothing but what? H now. Okay, A is H. Okay, then what is D? D is small d is effective depth. Then what is this ES? Young's modulus of steel, that is 2 into 10 raised to 5 Newton per mm square. It is fixed. Okay, then AST, that is area of steel. Okay, and what is this X? X is the depth of neutral axis. Okay, so from this you can calculate this EM, but before that we have to calculate this E1, X. E1 and X we need to calculate. Then how this E1 is calculated? If the crack width is measured at the soffit, soffit means this is called the bottom surface of the beam. Bottom face of the beam is called as soffit. Measured at the soffit, that is bottom surface of the beam, then A is equal to H. So A will becomes H, and hence this formula E1. I will calculate E1 now. E1 is equal to Fs by Es, Fs divided by Es into H minus X divided by D minus X. Okay, so from this we can calculate E1. Sorry. So, but if you want to calculate E1, again we need to calculate Fs. Okay. So, and substitute this E1 and they will get EM. Okay, this term. But what is Fs now? What is Fs? So, Fs is equal to stress at the centroid of the tension reinforcement expressed in Newton per mm square. Okay. So, whatever the stress is there at the level of the steel, that is called Fs. Then how will calculate Fs? Fs is equal to small m, that is modular ratio into capital M into Y divided by IR. Okay, divided by IR. So then what is M now? What is M? So M will be modular ratio. M will be modular ratio, that is ES divided by EC. Then capital M is moment. Capital M is moment. Then what is this Y? Y is equal to distance of the centroid of steel from the neutral axis. So from the neutral axis, right, whatever the distance we are going to measure up to the center of steel, that is Y. And this Y is nothing but D minus X. D minus X. And what is IR? So IR will be moment of inertia of cracked section. In the previous problems you have solved this IR. So IR will be moment of inertia of cracked section, that is Bx cube by 3 plus MAST into D minus X whole square. So from this you can calculate IR. First calculate X. Okay. Then substitute X here. IR will be calculated. Y will be D minus X. M, it is given in the problem, right? M is modular ratio ES upon EC. So from substitute all these values here, we'll get Fs. Okay, then Fs will be substituted here. Fs will be substituted here. Then we're going to get this E1. Okay, so E1 will be substituted here. Okay, then this EM we will going to get. This EM we will going to get. Then this EM. Okay, and ACR, okay, C minimum. Substitute all these values, okay, we'll get crack width of the beam. So this is important. So every formula or equation will be given in the IS 456 code book. Not necessary to by heart. Okay, just refer the IS code book. Okay, once again, and try to calculate this crack width. This is the main formula. Okay, so in that we can calculate ACR, okay, we can calculate EM, and we can calculate C minimum. So ACR will be calculated using this formula. S will be given in the problem, that is spacing of bars S. C minimum Okay, we can calculate C minimum. Okay, minimum cover, it is given in the problem. Then calculate X, that is neutral axis depth first, as usual in the previous problems what we have solved. Okay, so then for calculating this EM, okay, use this formula. So in this first calculate E1. So E1 will be calculated using this formula. So if you want to calculate E1, first calculate Fs. So Fs will be calculated using this equation. Okay, so from this you can calculate Fs, substitute Fs here, get E1, substitute E1 here, get EM. Okay, so whatever calculated EM is there, substituted here EM, ECR will be calculated, C minimum will be calculated, X will be calculated. Substitute this, you will get finally crack width. Okay, we will get crack width of the beam at the bottom. So this is what the procedure we're going to follow. Now next class we're going to solve one or two problems so that you can attempt this in the examination. So if you have any doubts, so feel free to ask me. But once again, if you go through this procedure and refer the IS 456 2000. Okay, so thank you very much for attending the session. Okay, we'll in the next session we'll start with the problems on crack width calculation. Thank you very much.